Hi, good afternoon, 7th graders. Today, we will discuss your last quiz. I hope you are prepared with the problems or at least your work, so you can check which part of your work is wrong and then please make correction. We will start from number 1. A farmer has 2 vehicles with the same weight and the same number of wheels. Figure 1.1 shows what the wheels on these 2 vehicles look like. Which vehicle should the farmer use when driving across his fields when the ground is very soft? Give your reasons. Guys, be careful. In the worksheet, vehicle number 2 has larger surface area of wheels compared to vehicle number 1. In this quiz, I flipped the wheels of the vehicle. So now, vehicle 1 has larger surface area of wheels compared to vehicle 2. So, the answer for this question is no longer vehicle 2, but it is now vehicle 1. The reason is still the same as the discussion in the worksheet, because the surface area of the wheels in vehicle 1 is greater than vehicle 2, which produces less pressure to the ground. Now, let's continue with question number 1b. Question BI. If you stepped on the point of a sharp nail with your bare foot, it would be extremely painful. Explain in terms of pressure why this is so. Guys, this question is exactly the same as the question in our worksheet. So the answer to this question is also the same as the answer in the worksheet, which is the tip of the nail has a very small surface area, which produces large pressure. Question 1b II. A person can lie on a bed of nail points if there is a large number of nails. Explain why this is not extremely painful. This question is also the same as the question in our worksheet. So, the answer to this question, of course, also the same as the answer in the worksheet, which is the weight of the person spreads over large area, which produces less pressure. We will continue the discussion to question number 2. Figure 2.1 shows a diver 40 meters below the surface of the water. Question 2a. The density of water is 1000 kg per meter cube, and the acceleration of free fall is 10 meters per second squared. Calculate the pressure that the water exerts on the diver. Guys, the pressure of the liquid can be calculated using this formula. Pressure equals to rho times G times H. The P here is the pressure. Rho is the density of the liquid. In this case, the liquid is the water. G is the acceleration due to gravity, or also known as the acceleration of free fall. The problem states that the acceleration of free fall is 10 meters per second squared. H is the depth of the liquid or the water. From figure 2.1, we know that the diver is at 40 meters below the surface of the water. So the depth here equals to 40. Now let's fill in the numbers into the formula. Pressure equals to, the density is 1000, the G is 10, and the H or the depth is equal to 40 meters. So P equals to 400,000 Pascal. PA stands for Pascal. This is the unit of pressure. Now let's fill in the answer into the provided space. 400,000 Pascal. Question number 2B. The window in the diver's helmet is 150 mm wide and 80 mm from top to bottom. Calculate the force that the water exerts on this window. Guys, there is also one more equation to calculate the pressure, which pressure equals to force over area. We can modify the equation into force equals to pressure times area. We get the pressure from the previous calculation, which is the 400,000 Pascal. That's the pressure, 400,000 Pascal. The area here is the area of the window in the diver's helmet. It is 150 mm wide and 80 mm from top to bottom. So the area equals to 150 mm times 80 mm. But for this calculation, you need to convert or to change the unit of the measurement here from millimeter into meter. That's why the 150 millimeter becomes 0.15. To convert millimeter into meter, just divide the number by 1000. Then you will get this. Now also divide the 80 millimeter by 1000. You will get 0.08. So the area of the window is 0.15 times 0.08. Then we get the result, 4,800 Newton. That's the force exerted by the water on the window. Let's fill in the answer into the provided space, 4,800 Newton. Let's continue to question number 3. Figure 3.1 shows two examples of footwear being worn by people of equal weight at a Winter Olympics competition. Which footwear creates the lowest pressure below it and why? Guys, once again, you have to be careful in this question. Why? Because in the worksheet, I asked which footwear creates the largest pressure. Now, I change the question into lowest pressure. So, the answer for this question is no longer the skate, but now it is the ski. Why the ski? Because the ski has greater surface area, which in contact with the ice. So the ski will exert lower pressure compared to skate. So between the two footwears, the ski will create lowest pressure. Let's move on to question number 4. Figure 4.1 shows a reservoir that stores water. Question 4a. The valve in the exit pipe is closed. The density of water is 1000 kg per meter cube, and the acceleration of free fall is 10 meter per second squared. Calculate the pressure of the water acting on the closed valve in the exit pipe. For this question, we will use the equation pressure equals to the density of the liquid or the water in this case. G is the acceleration of free fall or the acceleration due to gravity or the gravitational acceleration. H is the depth. From the drawing here, we see that the depth of the water or the dam is 50 meter. So now let's fill in the numbers or the values of the quantities into the equation. Pressure equals to 1000 times 10 times 50. 1000, once again, is the density of water. 10 comes from the acceleration of free fall. And 50 is the depth of the water from the drawing. We get the result as 500,000 Pascal. Fill in the answer into the provided space. Pressure equals to 500,000 Pascal. We continue to question 4b. The cross-sectional area of the pipe is 0.5 meters squared. Calculate the force exerted by the water on the closed valve. Guys, once again, you have to use the other equation to calculate the pressure. Remember, we also have the equation pressure equals to force over area. So to calculate the force, we can modify the equation into force equals to pressure times area. The capital F here is the force, capital P is the pressure, and capital A is the area. The pressure is 500,000. We get it from the previous calculation. And the area of the pipe is 0.5 here. Fill in that into the equation. We get 250,000 Newton. So the force exerted by the water is equal to 250,000 Newton. Be careful. The unit of force is Newton. The unit of pressure is Pascal. Let's continue the discussion with number 5. A mass of 3 kg hits a wall. The average force exerted on the wall during the impact is 180 Newton. The area of the mass in contact with the wall at impact is 0.05 meters squared. Calculate the average pressure that the mass exerts on the wall during the impact. To answer this question, we have to use the equation pressure equals to force over area. So, we use this one. P is pressure, F is force, and A is the area. From the problem, we know that the force is 180 Newton, and the area during the impact is 0.05. The result of 180 divided by 0.05 is 3,600 Pascal. So pressure equals to 3,600 Pascal. We continue to question number 6. For a special parade, the guest of honor is to sit on a chair whilst the parade passes by. Unfortunately, the ground beneath the chair is soft. So, the parade organizers put the chair on a large flat board as shown in figure 6.1. Explain why the board prevents the chair from sinking into the ground. The answer to this question is the board increases the surface area in contact between the chair and the soft ground. The increase in surface area decreases the pressure, which prevents the chair from sinking into the ground. We will continue to question number 7. Figure 7.1 shows a pond that is kept at a constant depth by a pressure-operated valve in the base. Question 7a. The pond is kept at a depth of 2 meters. The density of water is 1,000 kg per meter cube. Calculate the water pressure on the valve. To answer this question, you will have to use the equation pressure equals to the density of the water times the acceleration due to gravity or the acceleration of free fall times the depth. If it is not stated in the problem about the value of the acceleration of free fall, then just use 10 meters per second squared as the value of g. Once again, if the problem does not state the value of g, then just use 10 meters per second squared. So pressure equals to 1,000, this is the density of water, times 10, the value of g, times 2. 2 is the depth of the pond. So pressure equals to 20,000 Pascal. Fill in the answer into the provided space. Pressure equals to 20,000 Pascal. Question number 7b. The force required to open the valve is 50 Newton. The valve will open when the water depth reaches 2 meters. Calculate the area of the valve. Guys, to do the calculation, we need to modify the equation pressure equals to force over area. Once again, to answer this question, we need to modify the equation pressure equals to force over area. After we modify the equation will become like this. Area equals to force over pressure. The initial equation is pressure equals to force over area. So you just have to exchange the position of area and pressure. The force is 50 Newton and the pressure is 20,000. We get the pressure from here. This equal to 0.0025 meters squared. Remember, from the equation here, you will get the area in meter squared unit. because the pressure is in pascal and the force is in Newton. Yeah, so you will get the area in meter squared unit. We can change or convert the unit into centimeter squared, so the value will not be too small. To convert meter squared into centimeter squared, you just have to multiply the value of 0.0025 by 10,000. Once again, to convert meter squared into centimeter squared, just multiply the value in meter squared, which is 0.0025 by 10,000. After you multiply 0.0025 by 10,000, you will get 25 centimeter squared. That's the answer for this question, 25 centimeter squared. Can you answer the question in meter squared? Yes, you can. So if you answer the question with 0.0025 meter squared, it is also correct. It will not consider as a wrong answer. Okay? Yeah. Now, let's continue our discussion to the last problem in the quiz, which is number 8. Figure 8.1 shows a cylinder at atmospheric pressure and is then slowly compressed. The diameter of the piston is 5 cm. Question 8a. Calculate the area of the piston. Use pi equals to 3.14. Guys, from the problem we know that figure 8.1 shows a cylinder. That means the piston will have a cross-sectional area in the form of a circle. So, the area over here is the area of a circle. To calculate the area of a circle, we can use the equation area equals to pi times r squared. Now be careful. The data in the problem is the diameter of the piston, while in the equation, we need the radius of the piston. So don't forget that you have to divide the value of 5 cm by 2 first to get the radius of the piston. So, the area of the piston equals to 3.14, that's the pi, times 2.5 squared, not 5 squared. The 2.5 comes from 5 cm divided by 2. Remember, radius is diameter divided by 2. Okay? The result for this equation is 19.625 centimeter squared. Let's fill in the answer into the provided space. Area equals to 19.625 centimeter squared. Let's continue to the last question, question 8b. A 785 Newton force is given to push the piston in. Calculate the pressure caused by the piston to the gas. For this calculation, we need to use the equation pressure equals to force over area. The force is 785 Newton. It is given in the problem. The area we get from the previous question, which is 19.625 centimeter squared. Now you have to be careful here. The unit of the area that we calculated before is centimeter squared. For this equation, the area must be in meter squared. So the centimeter squared unit need to be converted into meter squared first. To convert the centimeter squared into meter squared, you have to divide the value in centimeter squared, which is 19.625, by 10,000. That's why I divide the area of 19.625 by 10,000. This is a fractional division. So you have to flip the fraction. The equation becomes 785 times 10,000 over 19.625. You flip this, okay? Use your calculator, then you will get this equal to 400,000 Pascal. So this question can be tricky. Which part? This one. If you forgot to change the unit of the area from centimeter squared into meter squared, you will get a wrong answer. So be careful, yeah? Remember to convert the unit from centimeter squared into meter squared first. Let's fill in the answer into the provided space. Pressure equals to 400,000 Pascal. Okay, this is the end of our discussion today. I will not give you any assignment for today. We will meet again on Thursday. In Thursday, we will have Zoom meeting for 1 hour from 12 o'clock until 1 o'clock. And then after that, you will have to do one assignment from me consisting of some problems still related about pressure. So make sure that you submit your assignment before the due time. Okay? So goodbye for now. Until we meet again on Thursday. Don't be late for the Zoom meeting. Okay, guys? Bye all.